Network layer is responsible for forwarding and delivery of packet using an IP address. So when data coming from the upper layer, the network layer adds 20 to 60 bytes header, which contains information of the routing and delivery. So to understand the header of IPv4, watch the video till the end. If we see any IP datagram, there is 20 to 60 bytes long header added to it containing informations for routing and delivery. So when we look into that, first 4-bit fields defines the version of IP protocol. Currently, the version is 4 and all fields must be interpreted as specified in the 4th versions of protocol. If the machine is using some other version of IP, the datagram is discarded. Next 4-bit fields defines the total length of datagram header in 4 bytes words. This field is needed because the length of header is variable between 20 to 60 bytes. When there are no options, the header length is 20 bytes and the value of this field is 5. That is 5 multiplied by 4 is equal to 20 bytes. When the option field is at its maximum size, the value of this field is 15. That is 15 multiplied by 4 is equal to 60 bytes. Next 8 bits referred to as type of service. The part of the field was used to define the precedence of the datagram. The rest defined the type of service like low delay, high throughput and so on. Next 16-bit field defines the total length, header plus data of the IP datagram in bytes. Since the field length is 16 bits, the total length of IP datagram is limited to 2 raised to 16 minus 1 is equal to 65,535 bytes, of which 20 to 60 bytes are the header and the rest is data from the upper layer. The maximum length of IP datagram equal to 65,535 bytes. But sometimes in physical layer, we must divide the datagram to make it possible to pass through these networks. This is called fragmentation. To manage the fragmentations, IP header contains 16-bit identification, 3 bits flags and 13 bits fragmentation offset. Using these fields, we can assemble the packet at receiving ends. Next 8 bits are for time to live. This field is needed because sometimes routing table in the internet can be corrupted. A datagram may travels between 2 or more routers for long time without ever getting delivered to the destination host. This field limits the lifetime of datagram. When a source host sends the datagram, it stores the number in this field. This value is approximately 2 times the maximum number of routers between any two hosts. Each router that processes the datagram decrements this number by 1. So suppose we set initial TTL value 6. Then at first router it will be 5. At second router it will be 4. Then at next router it will be 3. And then it will reach to the destination. If due to corruptions of routing table, a datagram may travels between 2 or more routers for a long time, this field becomes 0 and the router discards the datagram. So ultimately the TTL field restricts the datagram to travel forever in the networks. Next, 8-bit field defines the higher level protocol that uses the services of the IP layer. An IP datagram can encapsulate data from several higher level protocols such as TCP, UDP, ICMP, IGMP, etc. This field specifies the final destination protocol to which the IP datagram should be delivered. Next, 16 bits is for checksum, for checking errors in the datagram header. Next, 32 bits defines the IP address of the source. After that, next 32 bits define the IP address of the destination. These two fields must remain unchanged during the time of IP datagram travels from the source to the destination host. Next, 40 bytes may be used for the optional information such as source root, record root, etc. Normally used by the network administrator to check whether a path is working or not. So this is all about IPv4 header. I hope you understand most of it. See you in next video. Bye bye. If you like this video, press like and subscribe the channel and share the video. And don't forget to press the bell icon for my new video notifications. Thanks for watching.